Good afternoon to all. My name is Aishwarya. I'm working as an assistant professor in the Department of EC at Emmanuel as a JJ College of Engineering. Today, we are going to see a new topic is classification of systems. Okay, so classification of systems means nothing but it accepts all input signals like audio, video, and sensor data. So it applies a set of rules, operations, or some mathematical functions, formulas for the input signal. So again, it produces an output signal that may be altered in amplitude, frequency, phase, or in any of the forms. Okay, so the input signals may be audio, video, sensor data, and again that can be applied by using any of the set of rules or operations. Again, that produces the output signal which may be altered in amplitude, frequency, or phase. So some type of the classification is system. It is classified into main types, that is signal domain, linearity, causality, stability, and memory. Again, the signal domain is again classified into two types, that is continuous and discrete. Signal domains are classified into continuous and discrete. Again, the linearity has two types, linear and non-linear, in which the linear is again classified into a recursion type, which has a recursive and non-recursive type. Again, the linearity, non-linear, and time dependence, that is time invariant and time variant. Again, next type is causality, which is causal and non-causal. Then stability, two types, stable and unstable. And memory, dynamic and static. These are the tree diagram for the classification of system. Next. Classifications. As I said in the tree diagram, it is tabulated. Signal domain, linearity, causality, stability, memory, recursion, and time dependence. Signal domain is two types, continuous, discrete. Linearity is linear, non-linear. Causality of two types, causal, non-causal. Stability of stable, unstable. Memory of dynamic and static. Recursion as recursive, non-recursive. Time dependence as time invariant and time variant. Coming to the examples of this single domain, they may be analog RC filter or discrete signal processing units. Linearity there comes under FIR filter or squaring circuits that we can study detail later videos. Okay, so causality, that is real time filter. Stability, there are stable filters. Memory, capacitor circuits are used. For recursion, IIR filter or FIR filters are used. For time dependence, fixed resistor or adaptive filters are used. Okay, all these examples on the system types we can study detail in the upcoming videos. Okay, so let's say what is this continuous time system is. It operates on signals defined for all values of times. It defines for all values because the name itself says continuous, so it defines for all values of time. Example, analog circuits. Okay, then discrete time means it is defined only at a discrete time instance. Okay, that is some of the sampled data only will be operated. Example, digital signal processing. Linear systems means obey the principle of superposition. Superposition theory is used here, that is additivity plus homogeneity. Example is FIR filter. The non-linear system means output is not directly proportional to input. Okay, the output is not directly proportional to, that is inversely proportional. Okay, again, causal system means the output depends only on present and past inputs. Causal means only the present and past is used. Non-causal means future is used. Okay, again, stable system means produces bounded output, that is BI, BO stability is used here. Again, unstable means unbound output is used, that is BIBO stability is not used here. Okay, stable means bounded output and unstable means unbounded output. Okay, again, dynamic system is it has some memory. Okay? Dynamic means it's case of memory, so it has some memory. Output depends on past inputs. Recursive means both past input and past outputs are used. Okay, past input and past outputs are used. Time invariant means behavior does not change with the time. Time invariant, that is does not change with the time. Time variant means properties changes over time. It varies with time. Okay, example, system with aging components or adaptive filters. Okay, so I hope you all understand what is the basic classification of systems in signal processing. So If you have any doubt, just mention it in the comment. Okay. Thank you.